Hello, and welcome to The Sleepy Scientist. Tonight, we are stepping away from the noise of the human world. We are leaving behind the rush of traffic, the glow of screens, and the endless list of things to do. Instead, we are stepping into the quiet, mysterious, and infinitely slow world of plants. A place where leaves listen, where roots explore the dark earth, and where trees just might be talking behind our backs. It is a slow-motion universe, a world filled with soft light, intricate chemistry, and clever little tricks that unfold one patient moment at a time. I hope this video isn't too interesting. In fact, my goal tonight is to be just interesting enough to capture your wandering mind, but boring enough to let it go. If this journey keeps you awake, at least you will be learning something fascinating. But if you drift off, if your eyelids become heavy and the words begin to blur, then I have done my job perfectly. Before we begin, take a moment to settle in. Adjust your pillows. Pull the blanket up to your chin. Let your body sink into the mattress, heavy and warm. Take a deep breath in and let it out. This video is for relaxation. It is not medical advice. It is not a cure for insomnia. It is simply a bedtime story told by the earth itself. Let's begin.
Plants are easy to underestimate. To us, moving at our frantic pace, they seem frozen in time. They don't pace the floor. They don't pounce. They don't bark or blink or scurry off into the underbrush when we approach. They just sit there, quietly, greenly. But if you take a closer look, if you really stop and notice, you will find that plants are not just passive decorations in the background of your life. They are astonishingly complex, beautifully structured, and incredibly resourceful. Their bodies are finely tuned systems built for survival, adaptation, and subtle interaction with the world around them. Let us explore this body. How does a living thing function in a world where moving an inch per day is considered a sprint? To understand this, we must look at the three main organs that make up a plant: the roots, the stems, and the leaves. They work together in an elegant, interdependent dance of water, nutrients, sunlight, and growth.
The roots, the hidden explorers. Let's start at the bottom, in the dark. Roots are the unsung heroes of the plant world. Hidden underground, they do the heavy lifting. They anchor the plant in place, holding it steady against the wind and the rain. But they are more than just anchors. They are sponges. They are sensors. They are explorers. Imagine the root tips pushing through the soil. They are soaking up water and minerals from the earth, drinking in the history of the ground. But they don't just sit there absorbing. They move. Roots can sense gravity. They know which way is down. They can sense moisture gradients growing toward the damp pockets of soil. They can even sense physical barriers. When a root encounters a rock in the deep earth, it makes a choice. It doesn't batter against the stone. It gently curves. It branches. It slows down in compacted earth or sends signals upward to the leaves, saying, "Wait, we need to adjust our strategy." Consider an old oak tree. Its root system creates a vast, underground mirror of the canopy above. Sometimes these roots extend outwards 2 or 3 times wider than the tree is tall. It is a sprawling, hidden architecture. In some forests, the roots of neighboring plants even fuse together, forming natural grafts, holding hands under the soil, sharing resources in the dark. The stem, the silent highway. Rising from the roots, we find the stem, or more broadly, the shoot system, branches, flowers, and fruit. The stem has a noble purpose. It holds the leaves up to the light. It is the pillar of the plant. But inside, inside, it is a busy highway. The stem transports fluids. It is a lifeline. Running through the center of the stem are 2 main transport systems, like biological pipes. One is called the xylem. The xylem carries water and minerals upward, from the deep roots all the way to the highest leaf. It is a one-way street, and it is powered by a remarkable force called transpiration. As water evaporates from the leaves high above, it creates a suction, pulling more water up from below. Imagine sipping through a straw made of living tissue. That is the xylem. The other system is the phloem. This is a 2-way street. It transports the sweet sugars, the energy created by the leaves, down to the rest of the plant. It feeds the growing tips. It feeds the storage organs. It feeds the hungry roots. Think of it as the plant's postal service, quietly shuttling packages of energy to wherever they are needed most. The leaves, the solar catchers. And finally, we reach the leaves, the stars of the show. Leaves are a marvel of engineering. They are designed for one primary purpose: to capture sunlight, to drink in the solar energy, and turn it into food. Their flat, broad surfaces maximize exposure to the sky. And underneath, on the shadowed side of the leaf, there are tiny pores called stomata. These are the lungs of the plant. They allow gases to enter and exit in a tightly regulated exchange. Carbon dioxide comes in. Oxygen goes out.
water vapor escapes. These tiny mouths can open and close. Depending on the humidity, depending on the temperature, the plant decides how much to breathe. Inside the leaf, the chloroplasts, those little green organelles, work tirelessly. They contain chlorophyll, the pigment that captures the light. With sunlight, carbon dioxide, and water, they perform the miracle of photosynthesis. They convert light into chemical energy, into sugar, and incidentally, they produce oxygen, something the rest of us are quite grateful for. Look at the variety of leaves in your mind's eye. The needles of a pine tree, thin and waxy, designed to survive the cold, dry winds of winter. The broad, velvet leaves of a tropical banana plant spreading wide to catch the dappled light of the jungle. The fleshy, thick leaves of a succulent, storing water like precious jewels in the desert. Each shape tells a story of adaptation, a story of survival. And this body, this plant body, is never finished. Unlike animals, whose bodies are largely fixed after a certain age, plants exhibit indeterminate growth. They keep building. New leaves, new stems, new roots. Year after year, season after season. They are self-building structures, solar-powered and able to recycle their own parts. It is an engineer's dream, self-building, self-repairing, and completely silent. There is no rush here, no panic, just a steady reaching for the sun, a slow stretching of cells, and a calm, quiet confidence in being exactly where it needs to be.
Now, let us drift deeper into the mystery. If you have ever looked at a potted plant and thought, well, it's nice, but it's not exactly thinking about anything, you are not alone. For centuries, we saw plants as passive green machines. Sunlight in, oxygen out. Not much else going on. But recent science has been quietly shaking up that perception. It turns out, plants are far more aware of their surroundings than we once believed. They don't have brains, they don't have nerves like we do, but they can sense, they can respond, they can remember, and they can even make decisions. Let's consider the phrase plant intelligence. It sounds like science fiction, but researchers are finding that plants possess a kind of distributed intelligence. Instead of a central brain processing information, the plant processes information in every cell, in every tissue.
The climbing decision. Take the humble pea plant, the kind you might grow in a vegetable garden. When a climbing plant looks for support, like a stick or a pole,
It sends out tendrils. These tendrils reach into the air, curling and searching. If researchers move the support, the plant adjusts. It changes its growth pattern. In some experiments, if two supports are offered, one thick, one thin, or one close, one far, the plant seems to evaluate both options before committing. It chooses the one that offers the best long-term stability. This isn't just a reflex. It is a choice, a calculation made without a calculator. The memory of the mimosa. And then there is memory. Can a plant remember? Consider the Mimosa pudica, the sensitive plant. If you touch its leaves, they fold up instantly. It is a defensive flinch. Scientists conducted an experiment where they dropped these plants from a short height, a small, harmless fall. At first, the plants folded their leaves in panic, but after being dropped repeatedly, over and over, the plants stopped reacting. They realized the drop was harmless. They stopped wasting energy. Here is the amazing part. They remembered this lesson for weeks. A plant with no brain retained a memory of safety. The senses of the green world. Plants may lack eyes, ears, and noses, but they are masters of sensing. They have photoreceptors to detect light, not just where it is, but what color it is and how long it lasts. They know if they're being shaded by a neighbor. They know if the days are getting shorter, signaling the coming winter. They can feel touch. This is called thigmotropism. A vine wrapping around a fence is responding to the physical sensation of the wire. The Venus flytrap snapping shut is responding to the tiny footsteps of an insect. They can smell. Plants are constantly sampling the air for chemicals. If a neighbor is being attacked by a pest, that neighbor releases a warning scent, a volatile organic compound. Other plants nearby smell this warning, and they ramp up their own defenses. They thicken their leaves. They produce bitter chemicals. They prepare for battle simply by listening to the chemical gossip of the breeze. They can even hear, in a way. Roots have been shown to grow toward the sound of running water. Even if there is no moisture present, just the sound of water vibrations is enough to guide them. They are listening to the earth. This is a distributed awareness. Every root tip, Every leaf cell is a sensor. There is no command center. There is no bossy brain telling the plant what to do. It is a democracy of cells. Decisions emerge from the collective input of the whole being. And in some ways, this makes them incredibly resilient. If an animal loses its brain, it dies. If a plant loses a branch or a root, it recovers, it regrows, it reconfigures. Its intelligence is built into the very fabric of its existence. So the next time you pass a tree, remember, it is sensing you. It knows where the sun is. It knows where the water is. It is evaluating. It is adapting. It is thinking in its own slow, green way.
Now, let's go deeper. Let's shrink ourselves down, smaller than an insect, smaller than a grain of sand. Let's slip beneath the surface of the soil. Above ground, the forest looks like a collection of individuals, separate trees, separate bushes. But below ground, everything is connected. You are entering the wood wide web. In a healthy forest, the roots of trees are not alone. They are wrapped in a delicate embrace by fungi. These are called mycorrhizal fungi. It is a partnership, a friendship that has lasted for millions of years. The fungi extend tiny threads called hyphae far into the soil, much farther than the tree roots can reach alone. These threads search for water. They mine for minerals like phosphorus and nitrogen, and they bring these treasures back to the tree. In return, the tree gives the fungi sugar, glucose, made in the sunlight above. It is a perfect trade. Food for minerals, sugar for water. But the fungi do something else, something magical. They connect one tree to another. Through these fungal pipelines, trees can communicate. They can share resources. Imagine a large old tree, a mother tree. She is tall, with a canopy bathing in the sun. She has plenty of sugar. Nearby, on the shadowed forest floor, are her seedlings, small, young trees that cannot reach the light. Through the fungal network, the mother tree sends sugar down, through her roots, through the fungi, and into the roots of the seedlings. She feeds them. She keeps them alive until they are tall enough to find the sun themselves. It challenges everything we thought we knew about survival of the fittest. In the forest, survival is about cooperation. It is about community. Trees can even send warning signals through this web. If a tree is attacked by bugs, it sends a chemical alarm through the roots. Neighbors pick up the signal and boost their immunity. Danger is coming, they whisper in the dark. Be ready. Scientists have found that some trees even support trees of different species. A birch tree might share nutrients with a fir tree in the summer, and the fir tree might return the favor in the winter. It is a collaborative economy. A forest is not a battlefield. It is a family. It is a vast, breathing organism, tied together by threads too small to see, but strong enough to hold the world together.
Let us rise now, up from the cool, dark soil, climbing the silent elevator of the stem, until we emerge into the light. Here, on the surface of the leaf, the most important event in the history of life is taking place. It is quiet, it is invisible, but it is powerful enough to shape the atmosphere of an entire planet. We call it photosynthesis. There is something magical about watching sunlight spill through leaves on a quiet morning. The light seems to turn liquid, green and gold, dancing on the forest floor. It feels serene, timeless, like the world is quietly recharging. And in a very literal sense, it is.
The solar catchers. To understand this magic, we must look inside the leaf cells. Floating within them are tiny green organelles called chloroplasts. Imagine them as microscopic emeralds or tiny solar power plants buzzing with silent energy. Inside these chloroplasts is a pigment called chlorophyll. Chlorophyll is the artist of the plant world. It absorbs the red and blue light from the sun, but it reflects the green. This is why the forest soothes us with its verdant color. We are seeing the light the plants decided not to keep. But the light they do keep is transformed. When a photon of sunlight hits a molecule of chlorophyll, it excites an electron. It is a spark, a tiny jolt of energy. This energy is used to do something incredible. It splits a molecule of water. Think of that. The water absorbed by the roots traveled all the way up to the leaf just to be broken apart by the sun. From this water, the plant takes hydrogen to build its batteries. Molecules like ATP and NADPH. And the oxygen? The oxygen is released. It is a byproduct, a waste product of this green industry. The plant lets it go, floating out of the stomata, drifting on the breeze, eventually finding its way into your lungs. Every breath you take is a gift from a chloroplast, the sweetness of air. But the process doesn't stop there. This is the light-dependent phase. But there is a second act, the Calvin cycle, sometimes called the dark reactions, because they don't need direct sunlight to happen. Here, deep in the fluid-filled stroma of the chloroplast, the plant performs its true alchemy. It takes carbon dioxide from the air, that invisible gas, and using the energy stored from the sun,
It weaves the carbon into sugar. Glucose, a simple sugar molecule. But in that molecule, the plant has trapped the sun. This glucose is the building block of everything. The plant uses it to build cellulose for its walls, to make starch for storage, to create the energy to grow roots and flowers. When you eat an apple, you are eating sunlight that has been turned into sweetness. When you burn a log in the fireplace, the heat you feel is the release of sunlight captured decades ago by a patient tree. It is all just light, held in a different form. If you watch a plant for a minute, it seems still. If you watch it for an hour, you might suspect it is sleeping. But if you watch it for a week, or if you speed up time with a camera, you will see that the plant is dancing. It twists, it turns, it reaches, it bows. It is a slow-motion ballet, choreographed by chemistry. Plants don't have muscles. They don't have a skeleton that hinges like ours. So how do they move? They move by growing. They move by changing the pressure of water inside their cells. And the conductors of this orchestra are plant hormones.
The Chemical Whisperers. Let's meet the lead singer of the plant hormone band, auxin. Auxin is the hormone of direction. It tells the plant where to go. It is responsible for phototropism, the plant's love for the light. Have you ever seen a houseplant leaning desperately toward a window? That is auxin at work. Here is the clever trick. Auxin hates the light. It retreats to the shaded side of the stem. When it gathers there, it tells the cells on the dark side to elongate, to stretch out. Because the dark side grows longer than the light side, the stem bends. It curves toward the sun. It is not pulling itself to the light, it is being pushed by the growth on its shadow side. Then there is gravitropism, the sense of gravity. Roots always know to go down. Shoots always know to go up. Even if you tip a pot on its side, within hours the stem will curve upward, correcting its course. Inside the cells, heavy starch grains settle to the bottom, telling the plant this way is down. Auxin rushes to the lower side of the root, but here it does the opposite. It slows growth down, causing the root to curve into the earth. The same hormone, two different messages, perfect balance. The architects of shape. There are others in this chemical cast. Gibberellins, the giants. They tell the plant to grow tall, to break out of the seed, to stretch. Cytokinins, the dividers. They tell cells to multiply. They encourage the plant to get bushy and full. Ethylene, the gas of aging. It tells the fruit to ripen. It tells the leaves when it is time to fall. If you put a banana in a bag with an avocado,
The avocado ripens faster. Why? Because the banana is whispering, breathing out ethylene gas, saying it is time to grow sweet. It is time to soften. And then the emergency brake, abscisic acid. Despite its name, it is the hormone of protection. When there is a drought, when the roots taste dry soil, this hormone rushes up to the leaves. It tells the stomata, close. Close now. Save the water. It is the plant's survival instinct kicking in.
The nastic movements. Sometimes plants move fast, not by growing, but by hydraulics. We call these nastic movements. The mimosa plant, shying away from a touch, it is driven by turgor pressure, water pressure inside the cells. When you touch the leaf, specialized cells at the base suddenly dump their water. They collapse. The leaf folds. It is like letting the air out of a balloon instantly. And then, slowly, patiently, the plant pumps the water back in, unfurling, resetting the trap, opening the solar panels once again. Or the morning glory, opening its trumpet to the dawn. Or the prayer plant, folding its leaves at night, looking like hands in prayer. These are daily rhythms, circadian rhythms. The plant has an internal clock. Even in total darkness, a plant knows when it is morning. It knows when it is night. Its leaves will still lift and lower, following a sun that isn't there. Because the rhythm is not just in the sky, it is in the genes. It is in the blood or the sap of the being itself.
The dance of vines. Perhaps the most beautiful dance is that of the climbing vine, a pea plant, or a passion flower. They perform a movement called circumnutation. The tip of the vine doesn't grow straight. It spirals. It circles in the air, searching, reaching like a blind hand in the dark. It draws slow circles in the sky. And when it hits something, a branch, a pole, a string, it reacts instantly. The cells on the contact side stop growing. The cells on the outside grow faster. The vine curls. It wraps. It tightens its grip. It pulls itself up, using the strength of others to reach the light. All of this is happening right now. In your garden, in the park, in the forest, even in the pot on your windowsill. You can't see it with a glance, but if you close your eyes and imagine the world in fast forward, you would see a planet in constant motion,
forests migrating, vines wrestling, flowers exploding into bloom, trees pumping water to the sky. It is a symphony of movement, silent to our ears, invisible to our eyes, but unmistakably alive. So, as you lie there, resting, imagine your own body slowing down to the pace of a plant. Your breathing, rhythmic, like the opening and closing of stomata. Your thoughts, drifting like pollen on the breeze. There is no need to rush. Nature takes its time, and so can you. If you walk through a forest, the first thing you notice is the silence. Maybe the wind rustles a branch. Maybe a bird sings. But the trees themselves, they seem mute. They stand like statues, keeping their secrets to themselves. But if you could tune your senses to a different frequency, if you could smell the way a butterfly smells, or feel vibrations like a root tip, you would realize that the forest is not silent at all. It is loud. It is chatting. It is gossiping. Plants are excellent communicators. They have been passing messages for hundreds of millions of years, long before humans spoke a single word, the invisible vocabulary. How do you speak without a mouth? You speak with chemistry. You speak with scent. Plants release volatile organic compounds, tiny molecules that float through the air. To us, this is simply the fresh smell of pine, the sweetness of a rose, or the sharp tang of cut grass. But to a plant, this is a language. Imagine a meadow. A caterpillar begins to nibble on a leaf of wild tobacco. The plant feels the damage. It senses the saliva of the insect. It doesn't panic. Instead, it takes a deep chemical breath and exhales a warning. It releases a specific cloud of scent into the breeze. This scent drifts downwind to its neighbors. The other tobacco plants smell the warning. They decode the message. Trouble is here. Prepare yourselves. And they do. Before the caterpillar even arrives at their leaves, the neighbors ramp up their immune systems. They produce bitter compounds to make their leaves taste bad. They thicken their cell walls. They are priming their defenses based on a rumor carried by the wind.
The specificity of scent. The vocabulary is surprisingly precise. A plant can release a different scent for a caterpillar than it does for a beetle. It can tell the difference between a bug bite and a pair of scissors. One is an attack, the other is just an accident. The plant knows. And the conversation isn't just about danger. It is also about invitation. Think of a flower. A flower is essentially a botanical billboard. It uses bright colors and alluring shapes to say, "Come here." But its most powerful tool is perfume. Floral scents are complex mixtures of hundreds of chemicals, and they change. Some flowers smell stronger in the evening to attract moths. Others smell sweet in the morning for the bees. Some blooms, after they have been pollinated, stop producing scent entirely. They turn off the open sign. "I am full," they say. "Go to the next one." It is a communication system that is real-time, efficient, and incredibly beautiful.
The underground telephone. We have already spoken of the fungal network, the wood wide web. But it is worth remembering that communication happens in the dark too. Roots send chemical signals through the soil. If a plant is struggling with drought, it can send a stress signal through its roots to its neighbors. "Save water," the signal says. "Close your pores," and the neighbors obey. It is a community looking out for its own. Some researchers believe plants can even recognize their family members. In experiments, when sagebrush plants were clipped, their neighbors responded more strongly if they were genetically related. They listened closer to their kin. It seems that even in the vegetal world, family ties run deep. So, the next time you breathe in the scent of a garden, remember, you are eavesdropping. You are walking through a crowded room
full of conversations you cannot hear, stories of survival, warnings of danger, and invitations to love, floating invisibly on the air. To be a plant is to be brave. Think about it. If a hungry animal comes toward you, you cannot run. You cannot hide. You cannot fight back with claws or teeth. You must stand your ground. You must endure. And yet, plants thrive. They are the masters of survival. Over eons, they have evolved an impressive playbook of defense. They are not helpless victims. They are silent warriors in a slow-motion battle. The first line of defense is the fortress itself, the body. Many plants wear armor. Look at the rose. Its stems are lined with sharp prickles. Look at the cactus. Its leaves have hardened into spines. Look at the hawthorn tree with its long, rigid thorns. These are the keep out signs of nature. They say, I am beautiful, but I am protected. Treat me with respect. But armor can be subtle. Some leaves are covered in tiny, fine hairs called trichomes. To our fingers, they might just feel fuzzy, like the soft ear of a lamb, lamb's ear plant. But to a tiny insect, walking on these hairs is like walking through a dense, sticky jungle. It is unpleasant. It is difficult. Some nettles even turn these hairs into tiny hypodermic needles, delivering a sting to anyone who brushes too roughly. It is a boundary, a physical declaration of personal space. The alchemist's chemical defense. If the armor fails, the plant turns to chemistry. Plants are the greatest chemists on Earth. They produce thousands of compounds designed to make them unappetizing. Some are bitter. Tannins, the compounds found in tea, wine, and oak bark, bind to proteins and make digestion difficult. To an herbivore, a mouthful of tannin-rich leaves is dry, bitter, and barely worth eating. It is a gentle deterrent, like putting too much salt in the soup. Others are stronger. Caffeine, nicotine, morphine.
We humans use these for our own purposes, but for the plant, they are weapons. Nicotine is a neurotoxin to insects. Caffeine can be toxic to bugs in high doses. The coffee bean and the tobacco leaf did not evolve for our morning habits. They evolved to survive. They evolved to say, "Do not eat me."
The strategists recruiting allies. But perhaps the most brilliant strategy is not to fight alone, but to hire a bodyguard. This is where the plant becomes a general. When some plants, like corn or lima beans, are attacked by caterpillars, they release a distress signal. This specific scent attracts parasitic wasps. These wasps are the natural enemies of the caterpillar. The plant calls them in. The enemy is here, it signals. Come and feast. It is biological warfare, executed with elegant precision. Or consider the acacia tree and the ant. The acacia provides the ants with a home, hollow thorns to live in. It provides them with food, nectar, and protein-rich snacks. In return, the ants become a standing army. If a giraffe tries to eat the leaves, or if a vine tries to strangle the branch, the ants swarm out and attack. It is a perfect partnership, a mutual agreement of protection.
The art of disguise. And finally, there is trickery. Some plants simply pretend to be something they are not. The passion flower vine creates tiny yellow spots on its leaves that look exactly like butterfly eggs. When a butterfly comes looking for a place to lay her eggs, she sees the spots. She thinks, "Oh, this leaf is already taken. Too many hungry babies here." And she flies away. The plant has defended itself with nothing more than a splash of paint, a visual lie. Or the stone plants of the desert, which look exactly like pebbles. An animal looking for a juicy snack walks right past them, thinking they are just rocks, hiding in plain sight. The philosophy of resilience. There is a cost to all this defense. Making thorns takes energy. Making poison takes resources. Plants must balance. If life is good, they grow. If life is dangerous, they defend. They make trade-offs. They are constantly calculating the risk. It teaches us something about resilience. Resilience is not just about fighting back. Sometimes it is about having thick skin. Sometimes it is about setting boundaries. Sometimes it is about asking for help. And sometimes
It is just about standing so still and so strong that the storm passes around you. As you drift deeper into sleep, imagine yourself like that ancient tree, rooted, protected. You have your own bark. You have your own safe space. Nothing can disturb your peace tonight. You are safe in the fortress of the green world.
Every great story has a moment of connection, a meeting, a partnership. In the plant world, this moment is pollination. It is not just biology. It is a pageant, a parade, a delicate, dazzling dance between a flower and a visitor. It is the reason the meadow blooms. It is the reason the apple tree bears fruit. It is an ancient exchange rooted in generosity.
The invitation. At the heart of this drama is the flower. The flower is the most optimistic part of the plant. It opens itself to the world, vulnerable and bright, offering a gift: nectar, sugar water, scent. It says to the passing wind, to the buzzing bee, to the hovering bird, "Come closer, I have something for you." For some plants, the partner is the wind. Grasses and pines do not need to be showy. They do not need bright colors or perfumes. They simply produce clouds of pollen, lightweight, like golden dust, and let the breeze carry it away. It is a game of chance, a biological confetti thrown into the air, hoping to land in the right place. It is nature's way of whispering to the wind. But for others, the partnership is specific. Consider the bee. Bees are the master pollinators, and flowers have evolved specifically to please them. Bees see the world differently than we do. They see ultraviolet light. To a bee, a flower is not just a splash of color. It is a glowing runway. Many flowers have nectar guides, patterns on their petals invisible to us, but shining like landing lights for the bee. They point the way to the center. Here, they say, the treasure is here. Bee flowers are often blue or violet, colors the bees love. They are shaped with landing platforms sturdy enough for the insect to rest while it sips. It is a moment of perfect fit. The bee gets the nectar, the flower gets its pollen moved. No one loses, everyone gains.
The bird and the trumpet. Then there are the birds, specifically the hummingbirds. Birds have excellent vision, especially for the color red, but they do not have a strong sense of smell. So, flowers pollinated by birds rarely bother with perfume. Why waste the energy? Instead, they dress in vivid reds and oranges. They shape themselves into long, slender tubes, perfectly matching the length
of a hummingbird's beak. The bird hovers like a jewel in the air, drinking deep, dusting its forehead with pollen before darting to the next bloom. It is an aerial acrobatics show performed in silence. The night shift. And let us not forget the pollinators of the dark, moths, bats. When the sun goes down, the bee flowers close their petals, but the night-blooming flowers are just waking up. These flowers are often pale, white, or cream, designed to glow in the moonlight. They release heavy, sweet scents that drift far in the cool night air. Jasmine, yucca, evening primrose. They guide the moths through the darkness like a lighthouse guiding a ship. It is a quiet, fragrant romance that happens while we sleep.
The specificity of love. Sometimes the relationship is so close, it is almost a marriage. The yucca plant and the yucca moth. They are completely dependent on each other. The moth gathers pollen from one flower and deliberately places it on the next. She lays her eggs inside. The larvae eat a few seeds but leave enough for the plant to reproduce. Without the moth, the yucca would die. Without the yucca, the moth would vanish. They have evolved together, shaped each other over millions of years. This is the beauty of pollination. It reminds us that nothing lives in isolation. The flower needs the bee. The bee needs the flower. It is a web of connection, a delicate waltz that keeps the world blooming season after season.
Plants are not just gentle garden dwellers. They are pioneers. They are daredevils. They have found ways to survive in the most punishing environments on Earth. From the sizzling sands of the desert to the frozen winds of the tundra, plants are there, quietly proving that life finds a way. The silence of the desert. Let us travel first to the desert, a place of blinding sun and scorching heat. Here, water is more precious than gold. And here we find the succulents, the cacti, the agaves. These plants are the hoarders of moisture. Their stems are thick and fleshy, swollen with water stored from the rare rains. They have traded their leaves for spines. Why? Because leaves lose water. Spines protect it. Spines create a tiny layer of shade. They break the wind. They deter the thirsty animals. Imagine the saguaro cactus standing like a sentinel in the Arizona sun. It grows so slowly, it might take 70 years just to grow its first arm. It stands there, motionless, waiting. It knows the rain will come, and when it does, the cactus swells, drinking deep, expanding its pleated skin like an accordion. It is a lesson in patience, a lesson in saving what matters most. And there are the resurrection plants. In the dry season, they curl up into tight brown balls. They look dead, brittle, gone. But add a single drop of water and watch. They uncurl. They turn green. They come back to life within hours. They are not dead. They are just waiting. The chill of the mountain. Now, fly with me to the high mountains, the alpine tundra. Here the air is thin, the wind is fierce, the frost bites even in summer. How does a plant survive here? By staying low. Alpine plants grow in tight, low cushions, hugging the ground. The moss campion. It looks like a soft green pillow on the rock. By growing in a dome shape, it traps heat inside, creating a tiny, warm microclimate for itself. It is its own greenhouse. Its leaves are small and thick, often covered in fine hairs to trap warmth, like a fur coat. The Arctic poppy, fragile as it looks, tracks the sun across the sky like a satellite dish, focusing the weak heat onto its seeds. They are small, yes, but they are tough. They endure the blizzard to bloom for a few short weeks of glory. The breath of the swamp. Move now to the wetlands, the mangroves. Here the soil is waterlogged. There is no air underground. Most plants would drown, their roots would rot, but the mangrove is an engineer. It grows snorkel roots called pneumatophores. These roots stick straight up out of the mud, reaching into the air like fingers just to breathe. They allow the plant to take in oxygen even when the tide is high. They stand on stilted roots, holding the coastline together, creating a home for fish and crabs. Anchored in the shifting sands, standing strong against the waves. The dwellers of the air. And finally, the plants that need no soil at all. The epiphytes, the air plants. High in the canopy of the rainforest, they cling to the branches of taller trees. They are not parasites. They do not steal. They simply want a room with a view. They drink water from the humid air. They catch dust and falling leaves for nutrients. The bromeliad shapes its leaves into a tank, a cup to catch the rain. In this tiny pool of water, high in the sky, frogs raise their tadpoles, a whole ecosystem in a single flower cup.
The lesson of the extremes. These plants teach us about adaptability. They teach us that there is no bad place to be, only a need to adjust. If it is hot, store water. If it is cold, stay low. If it is wet, build a snorkel. If there is no soil, climb higher. They do not complain about their circumstances. They change themselves to fit the world, and in doing so, they make the barren places beautiful. As you lie in your bed, safe and warm, think of the cactus standing under the stars. Think of the moss hugging the mountain stone. They are out there right now, surviving, thriving, and you are safe here. You have adapted to your day. You have survived your own challenges, and now, like the winter poppy under the snow, it is time to rest.
And finally, we come to the beginning of the end, or perhaps the end of the beginning. The seed. A seed is a botanical time capsule. It is a tiny dormant vessel packed with everything needed to start life anew. A protective coat, a stash of food, and a tiny sleeping embryo waiting for its moment. But before a seed can grow, it must travel. A plant is rooted to the ground. It cannot move, but its children can fly, they can swim, they can hitchhike across the world. The sailors of the wind. Some seeds are born to fly. Think of the dandelion. When the flower fades, it turns into a globe of white fluff. Each seed is attached to a tiny parachute, a structure so delicate it looks like spun sugar. When the wind blows, they lift off. They drift on the breeze, higher and higher, crossing meadows, crossing rivers, floating in lazy circles. They are the sailors of the air. Or the maple key, designed like a tiny helicopter blade. When it falls from the tree, it spins, round and round, slowing its descent, catching the wind, traveling far from the shadow of its parent. The drifters of the sea. Other seeds are built for the water. The coconut palm drops its seed, the coconut, into the ocean. It is wrapped in a fibrous, waterproof husk. It floats. It can drift on the tides for weeks or even months, bobbing gently in the waves, crossing entire oceans, until one day it washes up on a distant sandy shore, far from home, ready to put down roots in a new land. It is a slow, solitary voyage across the blue expanse. The hitchhikers. And some seeds prefer to catch a ride. Burrs, with their tiny hooks, cling to the fur of a passing wolf or the sock of a hiker. They travel for miles, completely unnoticed. Or the seeds hidden inside delicious fruit. Blackberries, cherries, apples. An animal eats the fruit, travels a distance, and deposits the seed back into the earth, wrapped in its own fertilizer. It is a partnership. The animal gets a meal, the plant gets a ticket to a new home.
The long sleep. But the most amazing thing about a seed is its patience. Seeds can wait. This is called dormancy. If the weather is too cold or too dry, the seed will not sprout. It sleeps. It waits for the perfect conditions. Some seeds can sleep for years, some for decades. There are seeds found in ancient storage jars, thousands of years old, that have been successfully sprouted by scientists. Imagine that, sleeping through history, waiting for your turn to wake up. It reminds us that rest is not a waste of time. Rest is preparation. Just as the seed sleeps in the dark soil, gathering strength, waiting for the rain, so do you sleep now, gathering strength for your own tomorrow.
We humans have always lived in the embrace of plants. They build the walls of our homes. They weave the clothes on our backs. They brew the tea in our mugs. But our connection goes deeper than utility. It is biological. It is emotional.
The healers. Plants are our oldest healers. Long before modern pharmacies, there was the forest. Willow bark for pain, the ancestor of aspirin. The rosy periwinkle, giving us medicine to fight cancer. Every rainforest, every meadow is a library of chemistry, waiting to be read. Somewhere in a leaf you have never seen might be the cure for a disease we have not yet solved. They heal us physically, but they also heal our minds. Have you ever noticed how your shoulders drop when you walk into a forest? Or how a room feels instantly calmer when you add a potted fern? This is biophilia, our innate love for the living world. Studies show that just looking at trees lowers our blood pressure. It reduces stress. We are wired to feel safe where it is green. The presence of a plant tells our primitive brain, there is water here, there is life here, you are okay.